Hello and welcome to a new session of the series Oracle Cloud Infrastructure in 7 Steps. I'm Maged Hanna, and I'm joined in today by my colleague Iwan Slatter. Hi, Iwan.
Hi, Maged. Great to be here.
Same here. Together, Iwan and I will be covering the application modernization on Oracle Cloud Infrastructure. And so let's get started. Before I get into the details, I would like to start with an acknowledgement from Gartner in their most recent report that was published around July last year, where they explicitly mentioned that OCI is designed and very well architected to host Oracle applications. The report can be accessed on the following the link that I'm showing on the screen, and it could serve as a proof point for our continuous development to provide a platform that is best suited to run the most critical enterprise workloads with no compromise on security performance while keeping costs at its minimum. I also want to draw your attention to the Apps Unlimited program, where we commit to offer a decade worth of premier support for our package apps customers. With this program, we enter into a continuous innovation model, or I would say a continuous release model. And this is a paradigm shift in the way we develop those applications. Applications like e-Business Suite, JD Edwards, PeopleSoft, Siebel, and Hyperion, and the likes. And with this, we are providing premier support until 2032. This support statement is being revised on a year-to-year basis. So last year it was 2031. This year it has just been modified to be 2032, and the direction is to add one more year as we go along. This has been going on since 2015, and it continues in 2021. And what this means for our customer is that with this continuous delivery model, you'll get timely product innovations, new features, new functionalities every quarter of a year, and in some cases on a monthly basis for some of those applications, while you no longer have to undergo any major upgrade. So in order for you to update those functionalities, you won't be needing to undergo any underlying technology stack major upgrade. And now, based on our various engagements with our customers, whether it be globally or across EMEA, we see that our customers' main goal is to modernize their applications, but at the same time, they are also looking for a robust platform where they can run, build, and deploy those applications. Doing this the old traditional fashion is one, costly, very complex, and high risk. That's why we saw a need for an enterprise-grade platform that runs mission-critical applications with no compromise on security, while having the same controls you used to have on-prem. Most of the time, you are looking for a combination of cost, benefit, complexity, and compliance perspective. So you need to get the best performance with the lower cost while having your security controls and regulatory compliance measures in place. That's why we took this different approach when designing Oracle Cloud Infrastructure. So our main goal was to turn all those challenges into opportunities for our customers. Along with this platform that we built, we also made sure to design a dedicated program to help our customers in their digital transformation. So we call the program the LEAP program. And if we are to look into the benefits that such a program is bringing into the table, so I will start with the fact that we know for a fact that as an Oracle customer, you have done a lot of investments on-prem. You have done a lot of customization to your Oracle package applications. You've been running those for decades now. And we made sure that you leverage all those investments. So typically you bring all those investments with you to the move. And once you go on the platform, you get instant cost savings, which could serve as a foundation to fund your digital transformation initiatives and leverage the very rich PaaS ecosystem that comes with the platform. And I will tap into this in the following slide. In terms of the automation, there is a huge difference between infrastructure automation, which is pretty much a given with any of the hyperscalers in the market as we speak. as opposed to an application-aware automation. Application-aware automation, you'll end up having an application that's up and running and ready for you to consume. You will also be able to perform any lifecycle management activities from spinning off different environments to cater for the different non-production requirements that you have. Tear down those environments in a timely fashion, take backups, restore those backups, and probably delete the environments or even stop those environments that are not needed for a certain period of time. And lastly, performance and protection with a combination of Compute Gen 2 cloud services and industry-leading Oracle DBaaS services on Exadata box, which is a purpose-built database machine that is running Oracle database with the highest performance in the market, and the autonomous offerings that we provide with that. With all this together, we are confident to offer performance SLAs because of the fact that we run faster, it's more resilient and scalable platform, and with the security backed in. If I am to tap into some of those benefits, so when you move your package apps from on-prem to the cloud, it's the very same suite that you're running today, with all the customization, with all the licensing with that. So typically, like I said before, you take all those benefits and you take all those investments along with you to the platform. We also recognize that a truly comprehensive cloud solution includes infrastructure, software, processes, and people. That's why we decided to design the SLEEP program. And along with the program, we also decided to invest alongside with you. So we will get you up and running on Oracle Cloud faster with eligible workload migrations. And this is all being provided to you with our top-notch cloud engineering team. So basically, we help you in the migration endeavor as we go along. Finally, and since Oracle Cloud Infrastructure was designed from the ground up to meet the stringent requirement for mission-critical enterprise workload, we made sure that we provide not only SLAs for availability, but also for performance and management, which is very unique in the market now, because if you look around, you will find that most of the hyperscalers are providing SLAs for availability only. But here, since we are very confident to run a very scalable, very high-performing enterprise-grade platform, we also offer SLAs for availability and, for performance and management as we go along. These advantages exist because Oracle Cloud Infrastructure was designed specifically to support Oracle Apps workload. And I'm referring back to Gartner's statement that I highlighted in the beginning of my slides. But let's focus on the unique features and why it is very unique to run those applications on Oracle Cloud. So I will start with the fact that Oracle database is the heart of any applications, and being able to run Oracle database with different flavors, with different entry points, and with different scalable options. This is crucial to running all those package applications on Oracle Cloud with Exadata as Exadata Cloud Services, with RAC, which is the high availability solution for Oracle databases. It's fully supported, and with most of those applications are also supported with autonomous transaction processing, which is our flagship revolutionized self-healing, self-managing, and self-securing database. Second, Oracle, we also provide specific tooling. I mentioned about the application-aware tooling versus the infrastructure automation tooling, and that's pretty much lowers the risk and provides you with the peace of mind while doing the migration, because the migration is fairly seamless. It automates the lift and shift process from on-prem to the cloud, but then again, it also automates all the lifecycle management activities and capabilities, which reduces the human error, and which by turns lowers the risk big time. And finally, with the observability and management platform, it provides a whole new world of capabilities of monitoring, or I would say end-to-end monitoring those applications. As an end result, you'll be able to migrate your on-prem applications that are highly customized to a more agile, more performing platform, while leveraging your on-prem investments and benefiting from the application-aware automation that I just mentioned. And all this gives an unprecedented user experience. And with all those benefits comes the instant cost reduction that could unlock a world of opportunities for application modernization, which deemed to be very hard to achieve with all traditional on-prem deployments. And I'm going to give you examples on those very shortly. But before I do that, let me walk you through a couple of use cases that we've seen with our customers. So the first customer is a Danish multinational engineering company. It's FL Smith. They provide, or I'll say they supply mining and cement industries globally with everything from engineering, machines, complete processing, you name it. It has like 11,000 employees and a revenue of around $2.5 billion on an annual basis. They needed to modernize their siloed on-prem environment, I would say. And they wanted to go to cloud to gain this competitive advantage over the rivals. They ended up migrating their business critical applications, and this comprises of multiple ERP solutions, multiple financial solutions, varying from e-business suite, Hyperion, a whole lot of workload comprising of around 430 servers and around 400 plus terabyte worth of data. As a result, they reduced its carbon footprint by leveraging the OCI's flexibility and elasticity. They provided capabilities for their customers. They wouldn't have been able to provide those if they followed the old traditional way of running IT. And they leveraged the monitoring tool that I just mentioned in my previous slide to gain this end-to-end monitoring and to gain this insight on how their online applications are performing, I would say. And we're currently working with them on an HPC proof of concept with the goal of to move their high performance compute workload into OCI. A second customer that I have is Ma'aden. Ma'aden is a Saudi Arabian mining company. They had a cloud-first strategy, and they already started it on an Azure. They also embarked on a huge transformational ERP project. So they wanted to transform their on-prem e-business suite onto Fusion ERP on OCI in the cloud as well. But they soon realized that it is a long-term project and it's going to take them at least a couple of years to be up and running. So they used to run their e-business suite on Hyperion on Exa machines on-prem. They were outdated and they were due to a hardware refresh. So they soon realized that an instant move to OCI is a no-brainer. Like I said, with the move, they gained those instant cost savings, which helped them in their overall strategy. And since the platform provides the three different layers to the IaaS, PaaS, and SaaS, so they were able to transition from running e-business suite the way they used to run on-prem on OCI, gaining all those cost benefits and agility when it comes to maintaining this environment, and then being able to transition to Fusion ERP seamlessly. With that all said, we talked about the rich PaaS ecosystem that is ready to be consumed within the same platform. And I'm showing here some examples of what we see our customers are doing in terms of their digital transformation, leveraging this combination of running their application on IaaS or on OCI while benefiting from the PaaS ecosystem. So this could be done through perhaps leveraging the integration PaaS services that comes along with the platform, because we know for a fact that any ERP solution is not working in silos. It's interconnected with the other ecosystem, and this could be done seamlessly with the iPaaS solutions, or probably extending those application leveraging Visual Builder and with the objective of providing multi-channel access, or even enabling conversational access to those applications with something like Oracle Digital Assistant, or even through providing real-time analytics with Oracle Analytics Cloud Services. It could also be a way to boost their digital online experience while maintaining a strong security posture through the strong security offerings and manageability offering that comes along with the platform, or the ability to build new cloud native capabilities, which is something that would be pretty much explained by my colleague Iwan in the next section. So Iwan, over to you.
Thank you very much, Maged. Okay, so what is cloud native? Well, Maged in his piece made a very, very important point, I think, about having application-aware automation. And cloud native is really about having cloud-aware software. So this is software that has actually been designed to run on the cloud. Because a lot of times what people have done is they've taken old applications and they've rehosted them to the cloud. Now, there are some benefits in terms of the infrastructure here, but you're not deriving the full capability from the platform. It's a bit like somebody going and buying a smartphone and then just using it like their old Nokia. They just use it for phone calls and texts. Whereas to derive the value from the smartphone, you need to install apps. You need to customize it the way you want. You are then able to take advantage of the fact that you can do your banking, that you can make contactless payments, and all those things that keep us addicted to our smartphones. So with cloud native software, what we're actually going to do is to write software that understands the platform it's running on and is able to take advantage of it. So with cloud native, it changes the way we build our applications. So they take advantage of the cloud platform. This enables us to build better apps that deliver more value, and that enables us as developers to be more productive. Now, why does it matter? 2 words: digital transformation. And digital transformation, IDC did a report about this, and one of the things they said, as enterprises encounter increased demands to digitize products and processes, they will find it necessary to become primarily producers of software as opposed to consumers. And that's key. Enterprises are becoming primarily producers of software. And furthermore, from them to do this, they need to adopt cloud native development processes. So cloud native drives digital transformation. And in many ways, I would argue that digital transformation requires a cloud native approach to succeed. So how do we adopt a cloud native approach? A lot of it comes down to simplicity. We're going to make smaller things. So we can move from building monolithic applications where you've got lots of people working on one application. All of the work has to be released in one block. This is where you get your code freeze and 2 releases a year, to deploying the same functionality as a set or sets of independent microservices. These can be developed and released at different speeds. You can have multiple versions of them deployed at a time. They're independent. And because you're deploying more frequently, the changes between releases are smaller. So actually, the number of errors goes down and your reliability goes up. Here's an example use case. This is a customer that I was working with. They had an on-premises legacy application that they wanted to start offering as a cloud service. Now, on premises, they didn't have much of a challenge around scalability. In the cloud, they found that they needed to scale out. They needed that ability. They needed the ability to scale back, but also they needed to be able to scale out different parts of the application differently. So I sat down with their lead developer and CTO and helped them re-architect the application. So each of the different parts of it is now deployed as a microservice in its own container or set of containers. So if we need more worker nodes, we can scale out more instances of the worker container without having to scale out more instances of the web server. And this has enabled them to meet their scalability requirements at a price point the market will pay. We can go further. We can start to create serverless functions. Now, these functions are smaller pieces of code. They do just one thing, and they run and then they terminate. So here's an example of a code vulnerability scanning app. The code was on premises uploaded to a file system. There was a Java app that scanned the code. It created a report and somebody downloaded it. In the cloud native world, we can use events to drive functions. Now the code goes into a storage bucket that creates an event that triggers the function scans the code, writes the report, and then terminates. So it's not continuously running. By the same token, if we have a whole load of code arrived at once, we'll run multiple instances of the function. So the scale out is handled by the platform. And then there's another event which happens when the report's written to notify the customer. So they're not having to come back and check the website and go, is my report ready? And this is a key aspect to cloud native. It's about being lazy. Don't do things yourself that the platform does. In the first case I showed you, one of the advantages of using the platform is that the scale out can be automated. With functions, it's inherent. Now, the Cloud Native Computing Foundation say the same thing in a lot more words. The key ones to highlight is these techniques allow engineers to make high impact changes frequently and predictably with minimal toil. Key thing to focus, high impact, minimal toil. We're going to deliver a lot of value with least effort. And to do that, Oracle provides, as part of OCI, a set of developer services. There are services around API, there's services around CI/CD, streaming, containers, and then being able to monitor and notify. I'm just going to drill into some of these services here. The first one we'll look at is OCI, which is the Oracle Kubernetes engine. Kubernetes is a really important technology. It's great for orchestrating containers. The downside is it's doing a complicated job. It's a complicated beast. There's a lot of work around Kubernetes. If, on the other hand, you use a managed service like the OCI, then a lot of the work is taken away from you and is delegated to the platform provider, us. So all you've got to worry about is your application. So with OCI, your life cycle is you write the software, you push that to the container registry, you can use the one in the cloud or you can use your own. And that's managed by Oracle. The Kubernetes engine itself is managed by Oracle. And all you need to worry about is defining how you want your deployment to go onto the cluster. Here's a quick example. This is an IoT customer. They're also moving to a SaaS model. They've decided to adopt OCI. They were writing Kubernetes clusters. They were managing it all themselves. We said, why don't you look at OCI? They have not looked back. They're very, very happy. It's released so much value and so much developer time that they don't have to manage their own clusters now. Functions. As I said, Functions is a serverless offering, so you have small pieces of code. It's based on an open source project called FN Project. The key things are you pay for use. Once your function's not running, you're not paying for it. It's autonomous. The platform will auto scale the functions out. As you saw, you don't provision or manage anything. And it's event driven. You can either invoke the functions directly, or you can invoke them through triggers like events. You saw that in the previous example as well. These are infrastructure events. They conform to the cloud events standard of the CNCF. And so we're not talking about an application event, but something that happens in a resource. Say one of your compute nodes is provisioned, or something happens, an object is created in a storage bucket. Within the event service, you configure rules, and then based on those rules, something can be triggered off. So it could be a function, you could send a notification, or you could send the event to the streaming service for analytics. Notifications. These are more like your sort of standard classical messaging. We can get them from the event service, we can get them from monitoring, or from your own services or applications. The messages are published to a topic, and then subscribers to that topic will be able to take that information and process it on. So it could be the endpoint of another application or service. It could be, say, email or Slack. Streaming. Streaming is about ingesting large amounts of data. So it's messaging, but it needs to be real time. The messages need to be replayable. They need to be in order. Classic use case would be IoT. The default piece of software for this is Apache Kafka. But Kafka is also, like Kubernetes, a complicated beast. So we have a managed service where your producers write to the stream. The stream can be partitioned, so you can write in parallel. And then you have consumers, which can be grouped together, that read off those messages and process them. As I said, Kafka is the default standard. So to enable people to use their software written for Kafka with our service, we have API compatibility. And mentioning APIs, we also have the API gateway. This is, I think, a little bit of an unsung hero of the OCI cloud native services. It allows you to publish and manage your APIs. It allows you to bring APIs together. It allows you to expose part of an API. You can do custom authentication. You can do metrics, logging, use that to monitor your SLAs. And it allows you to create scenarios like this, where you use the API gateway to expose an API to clients. And that could be made up of all or part of the APIs of a set of functions, containers running on OKE, software running on VMs or even bare metal servers, or SaaS services. You can also use the API gateway to generate SDKs to help develop against it. So in this use case, this is a customer who use extensively SaaS, and they use ERP, and they expose those three API. But the business was coming to IT and saying, well, we want extra bits of functionality, and we want to enable new business models. This is all part of the digital transformation. And of course, IT has not a lot of resources, and they're under time pressure. So the approach we've taken is API first. It's minimalist or lazy. It's cloud native. Wherever possible, we use the API of the SaaS or the ERP software. Where that isn't possible, we write first functions if we can, or if it needs to be a bit bigger, we write microservices. And then we frankly leverage the hell out of the platform using services like streaming, using services like events. And then we expose these APIs or publish them via the API gateway for people to consume. And they neither know nor care whether they're being redirected to SaaS or whether they're being redirected to functions. So thank you for listening to our presentation today. I hope you're interested in what OCI can do for you and how it can help you move to cloud. If you want to start a trial, cloud.oracle.com/try it. There is a perpetual free tier of offerings that you can use. You can install packaged app demo images from the Oracle Cloud Marketplace. And if you want to work through and understand how things work, there are also what we call live labs for both packaged apps and cloud native. I hope you've enjoyed this video. If you want further information, please contact your Oracle representative and they'll be able to help you.